The remainder theorem is one of the best time savers in polynomial algebra, and it shows up on the SAT in disguise. Instead of doing long division, you evaluate the polynomial at one number and you read off the remainder. Let us state it clearly, then use it in 3 worked examples. Keep one mantra in mind: the divisor tells you which number to substitute, not the other way around. If you divide f of x by x minus a, then the remainder equals f of a. The factor theorem is the special case. If f of a equals 0, then x minus a is a factor of f of x. Notice the input you plug in is a not negative a because the divisor is x minus a. Memorize that pairing. Whenever you see x minus a in the denominator, your evaluation point is x equals a. That single evaluation replaces an entire division table, which is why it is worth spotting x minus a or x plus b forms instantly on the exam. Next, we will test a factor, compute a numeric remainder, and finish with 2 zeros that reveal 2 factors at once. Example 1, easy. Let f of x equal x squared plus 3x minus 4. Is x minus 1 a factor? For x minus 1, plug in 1. 1 squared plus 3 minus 4 equals 0. Since the remainder is 0, x minus 1 is a factor. You could factor further into x plus 4. Example 2, medium. Find the remainder when x cubed minus 2x plus 1 is divided by x minus 3. Here a is 3. Compute f of 3. 27 minus 6 plus 1 equals 22. So the remainder is 22. That is the entire division answer for the remainder part. In the division identity, f of x equals a quotient times x minus 3 plus that remainder, but you only needed 22 from the theorem. Example 3, harder reasoning. Suppose f of 2 equals 0 and f of negative 1 equals 0. By the factor theorem, x minus 2 is a factor because plugging in 2 gives 0. And x plus 1 is a factor because plugging in negative 1 gives 0. Remember, x minus negative 1. So you immediately know 2 linear factors without touching polynomial long division. Those factors correspond to x-intercepts on the graph, which is another way the SAT tests the same idea. Common mistake, plugging in negative EA when your divisor is x minus a. For x minus 3, you evaluate f of 3, not f of negative 3. For x plus 5, rewrite it as x minus negative 5, then plug in negative 5. SAT pro tip, use the remainder theorem to check factors in seconds. If you get 0, you're done. If not, you can eliminate answer choices that claim a clean factorization. This is especially powerful on multiple choice, where brute force division would cost minutes. Recap. First, dividing by x minus a leaves remainder ef of a. Second, a 0 remainder means a factor, which is the factor theorem. Third, match the divisor to the correct input every time and let evaluation replace long division. Practice more on NovaMaths.